Hello, how are you, my Achiever Batch students? This is the ultimate recap for the chapter Complex Numbers Part 1. Yes, only Part 1 we will be doing for now, as we have already done in the classroom. Right? So, entire summary is here in front of you. Very easy, nice, simple, sober chapter. Nothing to worry much, nothing to hurry also. The first thing that we studied was introduction to Iota. Now, what was this Iota? So, you know human beings, right? Human beings like to do a lot of things. They like to do a lot of things. Wanted, unwanted, both. So, similarly, people in an era were confused that when an equation called x square minus 1 equal to 0 was solved, they could get the answer value of x as plus minus 1. But when an equation x square plus 1 equal to 0 was solved, we couldn't get any answer because x is equal to root of negative number, and then that was a problem. Obviously, plus and minus root of negative number. Till then, there was no value allotted to root of negative numbers. It was all said that square root of only positive numbers exist, like square root of 4 is 2, square root of 9 is 3, and so on and so forth. So people said, let us give it a new name, and they discovered, rather, for convenience, everything is about convenience. So for convenience, they said, let us talk square root of minus 1 is equal to I from now onwards. And this I is your iota. For our purpose, for our studying purpose, we will need this 5 things known to us. I is root of minus 1. So I square will be square this minus 1. I cube will be equal to I square into I minus I. I raised to 4 will be 1 and 1 upon I. 1 upon I, multiply and divide by I. Numerator is I, denominator is I square. That's I. I square is minus 1. So 1 upon I is equal to minus I. These 5 things, if we know, questions can be dealt with easily. Now we want to understand integral powers of iota. Integral powers of iota. How to solve questions on higher powers of iota. Let's take, for example, you have any power n, I raised to n. First 5 values, first 4 I asked you to by heart, and this fifth one also I asked you to by heart. You have to remember. But what if the power is not 4? It is something bigger number, 36, 57, 129, 540, any other number. In that case, all you will do is divide the power with 4. You will divide the power with 4, and whatever is the remainder, that should be written. Divide the power with 4 and write down the remainder. Let's say the remainder is r. So I raised to n will be equal to I raised to r. Example, I raised to 49. Divide 49 with 4. 4 ones are 4, 4 twos are 8, remainder is 1. So I raised to 49 is same as I. I raised to 1026. Divide 1026 with 4. Okay, 4 twos are 8, 2 carry, 4 fives are 22 carry, 4 sixes are 24, 2 carry. We have I square, which is minus 1. So all the powers will boil down to either I raised to 1, I raised to 2, I raised to 3, or I raised to 4. What will be I raised to 0? Like any other number, anything raised to 0 is 1. I raised to 0 is also 1. Okay, if there are negative powers also, you can deal with similar way. Let's say it's I raised to minus 33. Okay, negative power means it comes in the denominator. Divide 33 with 4. What is the remainder? 4 8s are 32, 1 is the remainder. 1 upon I is minus I. So the answer to this is minus I. Got it? Wonderful. So this is how we deal with integral powers of iota. Next is sum of 4 consecutive powers of iota is always going to be 0. That means if you have I raised to 3 plus I raised to 4 plus I raised to 5 plus I raised to 6. These are sum, that means addition. Powers are consecutive. Sum of consecutive powers of iota will always be 0. If you don't believe, you can quickly check. I cube is minus I raised to 4 is plus 1, I raised to 5, divide power with 4, remainder is 1, and I raised to 6 will be I square, that's minus 1. Plus 1 minus 1 plus I minus I will cancel up to give you 0. Are you able to understand? So in general, if one has to write this, in general, it is I raised to n, I raised to n plus 1, I raised to n plus 2, I raised to n plus 3 equal to 0. N plus 1, n plus 2, n plus 3 are integral powers. The power should be integral, not fractional. Okay. Okay. Before I go to questions on iota, there are simple questions. Let's say they will ask you what is the value of root of minus 9. You will say it is root of minus 1 is I and root of 9 is 3. So 3i. That's one type of question. The other question can be, solve this. X square plus 16 equal to 0. X square equal to minus 16. X equal to plus or minus root of minus 16. And plus or minus root 16 will be 4. Root of minus minus 1 is I. So x is plus or minus 4i. Do not forget the plus or minus. Now you'll say, ma'am, here you have not written plus minus. Here there is plus minus. Obviously, because it's only square root and here you are taking square root on both the sides. Always there is a difference. When there is a simple square root, we only take the positive value of square root. But if it's square root on both sides, like in this step, taking square root on both sides, plus and minus both will be covered. And then there are various questions you will see in your textbook based on iota, simple questions, powers of I and so on and so forth, they will try to give you. Okay, another thing related to iota is splitting of square roots. What is splitting of square roots? I hope this comes out well. No, let's go back. No time to play, right? No time, ma'am. Okay, beta. Splitting of square roots. And what happens in that? Root of minus a into root of minus b. Now a general tendency says mix up the root, minus a into minus b, minus in multiplication will go up and the answer is root of ab. That's what the general tendency says, but complex number will not say this. It is wrong because root of minus a, or if I take a concrete example, root of minus 9 into root of minus 4, will it be equal to root of 4 nines are what? 36. And will the answer be 6? Is it correct? No, it is not correct because root of minus 9 is 3i, root of minus 4 is 2i, and 3i into 2i, 3 2s are 6i square. I square is minus 1. So the answer should be minus 6. But with the first logic, we are getting plus 6. So there is a discrepancy. Can you understand? I want the answer to be minus 6 according to the logic we just studied. But the upper one is telling me the answer is plus 6. Problem. And to solve this problem, we will consider that whenever you have root of minus a into root of minus b, minus sign should come out and you will be left with this thing. Got it? Root of minus a into root of minus b, minus out and root of ab. So if the question is what is root of minus 9 like here into root of minus 4. You will take minus outside. 4 9s are 36, which is minus. Question solved. Done. Splitting of square roots. Great. Well done. Okay, now iota, if it is understood to you, let's go to complex number. What is this complex number? Well, it is the biggest set of numbers that you have studied. Natural numbers, integers, whole numbers, integers, then you put your rational numbers, some irrational numbers, all of them together form real number, and this real number, everything inside will be complex number. Your natural, whole, integers, rational, irrational, real numbers, everything is a part of complex number. It is the biggest set. Complex number is written by the letter Z. And the standard form of any complex number is Z is equal to A plus IB. Where very carefully you have to understand the real part of complex number is A, whereas the imaginary part of complex number is just B, not IB. Many students write imaginary part as IB. No, imaginary part is simply B and real part is simply A. Okay, fine. Now we will also get into the algebra of complex numbers like addition, subtraction, multiplication, division. That is all is there in the first part. Equality also, do not forget. Well, there is something called as purely real and purely imaginary complex number. Purely real complex number, purely imaginary complex number. Purely real is when in a complex number the imaginary part is 0. When imaginary part is 0. Not I is 0, not I is 0. Imaginary part, that is B, will be 0. That is Z will be having only a real part in it. And imaginary part, imaginary complex number is when real part is 0. That is, it will have only imaginary part inside it. Can you all tell me Z equal to 2? Let's change the color. Yeah. Z1 equal to 2. Is it purely real or purely imaginary? Yes, the imaginary part is not there. So it is purely real. Z2 equal to minus 4i. There is only imaginary part, no real part. Only imaginary part. So it is purely imaginary complex number. My dear boys and girls, that tells us 2, 4, 6. All these are complex numbers. Yes, we know them as real numbers, but they are essentially complex numbers whose imaginary part is 0. Like 9, ma'am, it's a real number. Oh, yes. But it is also a complex number with imaginary part 0, shiro, hero, right? Okay, talking about the equality of complex number. You cannot actually do inequality in complex number. Equality can be done. When any two complex numbers are equal, that means their real parts are equal and their imaginary parts are equal. Real equated with real, imaginary equated with imaginary. Example, ma'am, we need an example. Fair enough. Suppose 3 plus 9i equal to x minus iy. Equal to sign is there in between. How you're going to equate and find the value of x and y? X real with real. So this doesn't have y, this doesn't have y. They are real parts. X is equal to 3. What is the imaginary part here? 9. What is the imaginary part here? Minus y. Imaginary part equated with imaginary, and that is nothing but y equal to minus 9. Real with real, imaginary with imaginary. The point to be noted here is you cannot have inequality. Like you cannot say Z1 is less than Z2 or Z1 is greater than Z2. No. There is no parameter to measure the greatness of any complex number. I mean, you cannot say that 3 plus 4i is greater than 1 minus 2i. Although it looks like 3 and 4, positive will be greater, negative will be smaller, but no. You cannot do this inequality. Complex number is a very fair thing. Na? Always equal. No injustice, no inequality. How is addition subtraction happening in complex number? In a very easy way. Just you do the normal addition. Real added, imaginary added. Real subtracted, imaginary subtracted. Kaam khatam, paisa hazam. Z1 is x plus iy. Z2 is x minus iy. So Z1 plus Z2 when you're doing, add the real parts. This, let us take a plus b, a plus ib. Add the real parts, x plus a plus I times y plus b. Can you see real parts added and I times imaginary parts added? And if you have to do the subtraction, real parts will be subtracted plus I times imaginary parts will be subtracted, y minus b. So it works a lot like your normal algebra. Nothing high fun to deal in it. Express each of, okay, this has to be removed. Express each of the following complex number. Express the following complex number in the form of a plus ib. Obviously, it's a standard form. So most of the questions will be expressed in the form a plus ib. Also, a lot of questions will, when you have to solve, simplify, write the final answer, ensure it is in the form of a plus ib. You will always end the answer in the form of a plus ib. Now here is the question. Let's begin solving. 3 sevens are 21, 3 sevens are 21i plus 7i plus 7. I into I square. And my dear boys and girls, what is I square? 21 plus 7 will be your 28i. I square is minus 1. 21 minus 7 will be equal to 14 plus 28i. A plus ib. A is 14, B is 28. If I am correct, correct. If there is some error, you correct it. But you got the gist of it. You got what we are actually doing in the questions. Perfect. Let's deal with this properties of addition. The closure law. What does closure law says? That when you add any two complex number, the result is also a complex number. Oh yeah. Two complex numbers when you add. Okay, let's go back. Z1 plus Z2. Result is also a complex number. That's called closure law. You get a closure. The commutative law says Z1 plus Z2 is same as Z2 plus Z1. Just recall your sets chapter properties. In sets chapter, while doing union intersection, we studied about commutative, associative, identity, universal, idempotent. Do you remember these wordings? Right, those wordings. It will come again and again in next year also matrices chapter. You will encounter the same wordings. So remember, commutative means you just do not bother yourself with the order. Whether you write Z1 plus Z2 or Z2 plus Z1, it doesn't matter. We are talking about properties of addition, not subtraction. In subtraction, it will matter. Z1 minus Z2, is it same as Z2 minus Z1? No. So subtraction is not commutative, whereas addition is commutative. So we are talking about properties of addition. Order. Commutative, order. Associative is grouping. It doesn't matter how you group the elements. Z1 plus Z2 plus Z3, you add Z1, Z2 first and then to it Z3, or you do it the other way now. This is also fine. Both are correct. Existence of additive identity. That means what should be added to Z in order to get Z. Additive means add. Identity means what should be added to get identical thing out. Right, 0. So 0 is called as your additive identity. What is the additive identity of a complex number? 0. Next, additive inverse. What should be added to z in order to get the answer as 0? What is the inverse of z? Minus z. So minus z becomes the additive inverse of a complex number z. Will you be able to remember this property? It's very smooth, simple. Let's do some questions. Find the value of a and b. These two complex numbers on left and right have to be equated. Correct. So when you equate the real part, a plus b is equal to 5. And when you equate the imaginary parts, my dear kiddos, please see that there is a minus sign over here. So you cannot just blindly say 3a plus 2b is equal to 2. Minus sign has to be taken into account. So minus of 3a plus 2b is equal to 2. Taking minus on the other side and then solving the two equations. 3a plus 2b equal to minus 2. This is one equation, second equation. Try to solve them simultaneously. Alright, we will multiply the second equation with 2. That will give us 2a plus 2b is equal to 10. Let's call it equation 3. Subtract. 2b to be cancelled. 3a minus 2a is equal to minus 2 minus 10 minus 12. The value of a is minus 12 when your option matches. Right, there is only one option matching. Well, if you want to confirm, put a as minus 12, b will be 5 plus 12, 17. Absolutely correct. So we use the concept of equality of complex numbers. Once again, z1 and z2 is mentioned. What is z1 plus z2? As I said, add the real parts 4 and minus 3, 4 plus minus 3, and then add the imaginary parts 6 and plus 2. This is 1 plus I times 8. 1 plus 8i. Option C is the answer for this question. I want real part of z1 minus z2. This I is by mistake. What is real part of z1 minus z2? That means first find out what is z1 minus z2, everybody. Subtraction means real part subtracted and imaginary parts. Here the imaginary part is 1. 3. 1 minus 3 is minus 2i. This is z1 minus z2. Its real part is 1 and imaginary part is minus 2. There is no option. Okay, so maybe let us put here. Kya bolte ho? There should be minus 2 here, right? We want I into real part of, so real part of z1 minus z2 is 1. I real part. Sorry guys, my bad. Imaginary part of z1 minus z2 is minus 2. What will be I into real part of z1 minus z2? It will be I. Answer is B. So this I is very much there. It is not by mistake, not a typo. Real part 1 into I is I. Option B. Let's move on to the last part, which is multiplication and division of complex numbers. How do we multiply z1 into z2? So there is as such nothing like division, but you all know that division in a way is multiplication. z1 into 1 by z2. Division in a way is nothing but multiplication. All you're going to do in multiplication is normal multiply. Open the brackets. The way you open the brackets, multiply each term with each other term. In multiplication, you don't go for real with real and imaginary with imaginary. No, that doesn't happen in multiplication. Only addition, subtraction and equality. In multiplication, every term will be multiplied with every other term. Like if there is x plus iy and there is a plus ib, you will multiply x into a, then x into ib, then iy into a and iy into ib, that's I square b. Normal multiplication, the way we open brackets. Whereas if it is division, guys, if it is division, what you will do is always rationalize the denominator. If denominator is a complex number, rationalization. We will use the technique called as rationalization. More appropriate word would be conjugate. Multiply and divide with conjugate. Example, you have x plus iy upon a plus ib. You want to find the value of this. Always when I say find the value, the final answer will be in the form of a plus ib. Real part and imaginary part. Now such a question, you will multiply with a minus ib, divide with a minus ib. In the numerator, normal multiplication x plus iy and a minus ib. Normal multiplication will happen in numerator, like xa minus xib plus aiy minus iy into ib, yb I square. Later on you can put I square as minus 1 and simplify it. Whereas denominator is a plus b into a minus b. A plus b, a minus b is a square minus b square. I'll take here. It is a square minus b square. First term square minus second term square. A square minus b square, b square. I square is minus 1, that makes it plus. That makes it plus. So the denominator is a square plus b square. Remember this. Remember this, guys. In real number system, we studied a plus b into a minus b is a square minus b square in real number system. A plus b into a minus b, we studied it a square minus b square. That's correct. But now twist it a little and remember, a plus b, a plus ib into a minus ib is going to be a square plus b square, because this I square makes the negative into positive. So now onwards, directly you see a plus ib, a minus ib, add the two parts, that is add the real and imaginary part, squares of real and imaginary. Here is a question, express it in the form of a plus ib, it's normal multiplication. Minus root 3 plus root of minus 2 into 2 root 3 minus I. Firstly, minus root 3. Root of minus 2 can be written as 2i. Root 2i, my bad. Root 2i, isn't it? Root 2 is root 2. Root of minus 1 is I. Into 2 root 3 minus I. Let's start with the multiplication. First term with first term. Minus 2 root 3 into root 3. Let's write it as minus 2 into 3. First with second. Minus root 3 into minus 1 plus root 3i. This. Plus 2 root 3 into root 2, root 6i. And plus minus root 2i square. Simplify. Minus 6 root 3i plus 2 times root 6. We can't really simplify. Take I common. And I square is minus 1. That makes this plus root 2. Minus 6 plus root 2 plus I times root 3 plus 2 root 6. That's how we simplify it. Got it? Can we quickly check it? Alright, great. Next question. Okay, the properties of multiplication of complex numbers. Only multiplication, not division. Like only addition, not subtraction. Closure law, when you multiply any two complex numbers, you will get a complex number. The meaning remains same. Commutative. Ordering. Z1 into Z2 is same as Z2 into Z1, isn't it? Yes. But in division, it won't be same. Z1 by Z2 and Z2 by Z1. Different. Associative. Grouping. Z1 into Z2 into Z3 is same as Z1 into Z2 into Z3. You change the grouping, the final answer is not going to change. All of them are in multiplication, guys. Existence of multiplicative identity. Now that should be multiplied with what in order to get the answer? Identical value. So z should be multiplied with 1. This 1 becomes your multiplicative. The word identity is missing. 1 becomes the multiplicative identity. What is multiplied with z to give z? Identical? 1. Multiplicative inverse. Z should be multiplied with what in order to get 1? It should be multiplied with 1 by z. Or you can also say z inverse. Z raised to minus 1. This becomes your multiplicative inverse. What is multiplicative inverse of any complex number? 1 by z. Remember. And last but not the least, there is a distributive law also. Distributive property which says if you have z1 into z2 plus z3. Two complex numbers adding, outside there is a multiplying complex number. Normal z1 into z2 plus z1 into z3. This kind of multiplication is very much allowed. Right, guys and girls? Super. Identities of complex number. Identities in complex number are just as similar to your algebra. Example, a plus b the whole square, you all know. So z1 plus z2 the whole square is z1 square plus z2 square plus 2 times z1 z2. You all know a minus b the whole square also. Just a minus sign comes here. A plus b the whole cube, a cube plus 3a square b plus 3a b square plus b cube. Similarly, if there is minus sign, you put alternate plus minus. Basically, what I am trying to say here, every identity you have used in real numbers is applicable as it is in complex numbers also. A plus b, a minus b is a square minus b square. So, if you have z1 plus z2 into z1 minus z2, you can write z1 square minus z2 square. Very well. Good. Let's move to some few last questions. Express in the form of a plus ib. It's cubing and we just saw about the identities. So a cube plus that formula. First term cube plus 3a square into b plus 3a into b square plus b cube. 1 upon 27 plus 3 into 1 by 9 into 3i plus 3 cancel, 3 square 9 and I square you all know it is minus 1 later. 3 cube 27 and I cube is minus I which we are going to put. Okay, 3 3s are 9, 9 cancel, 1 by 27 plus I square minus 1 minus 9 and I cube minus I minus 27i. Take the real parts together, 1 by 27 minus I and I common, imaginary parts together, 1 minus 27. How much is 1 by 27 minus 9? Can we do the calculations? 27 nines will be 241. So 1 minus 241 is minus 240 upon 27 plus 1 minus 27 minus 26 I, and that's your answer. Please verify. Twenty-seven nines are, by the way, 27 it is, right? Not 29, yeah. 270 and then 27 less 243. 1 minus 243 will be minus 242. Minus 242 upon 27 minus 26i. Right, boss? Bilkul, ma'am. What is the multiplicative inverse of this complex number? If this is z minus 2 plus I, what is its multiplicative inverse? Ma'am, we just studied multiplicative inverse is 1 by z. 1 by z is multiplicative inverse, right? And how do I find 1 by z? 1 upon minus 2 plus I. Multiply and divide with its conjugate. Rationalize. Minus 2 minus I, minus 2 minus I. Multiply, divide with minus 2 minus I. Numerator is 1 into minus 2 minus I. Denominator is a plus b, a minus b. We just studied in case of complex numbers, a plus ib into a minus ib. A plus ib, a minus ib is a square plus b square. Minus 2 square 4 and 1 square 1. That's minus 2 by 5 plus 1 by 5 plus नहीं minus है बीच में minus 1 by 5 times I. This is the multiplicative inverse, minus 2 minus 1 upon 5. Option D. Find the value of x and y. Xy belongs to real numbers. Again a solving question. LHS is given to be equal to I. RHS is I. Simplify the LHS. It is not in the standard form. Bring it in the standard form. Cross multiplication, x minus 1 into 3 minus I plus y minus 1 into 3 plus I divided by a plus b, a minus b. Can you all see denominator is sorted, a square plus b square. 3x xi minus 3 minus of minus plus I. This should be I a very strong, okay, no, maybe not. 3y plus 3I minus 3 minus I divided by a plus ib, a minus ib is a square plus b square equal to I. Therefore, real parts, let's take all the real parts together. 3x plus 3y and there is minus 3 minus 3 minus 6. These three real parts. Imaginary parts together. What is imaginary? xi plus I. So x 1. Okay, this is 1i and 1 plus 3 4i. Plus I minus I can be cancelled also. X plus 3. And 3 square 9 plus 1. That goes in the RHS. That goes in the RHS, guys. Okay, sorry. Lot going back. Okay. 10 equal to I. This is I. Taking 10 on the other side and simplifying. Here I. Okay. 3x plus 3y minus 6 plus I times x plus 3 is equal to 10i. If 10i, that means real part is 0. It's purely imaginary. The real part is 0. What is the question? Find the value of x and y. Okay. Equate the real parts, equate the imaginary parts. 3x plus 3y minus 6 equal to 0. That will give us 3x plus 3y equal to 6. Divided by 3, x plus y equal to 2. One equation. On the other hand, we have imaginary parts giving us x plus 3 equal to 10, x equal to 7. And if x is 7, y will be 2 minus 7 minus 5. X is 7, y is minus 5. Please check if there is any mistake. Please resolve it. Put it in the comments also. One more question. 1 minus I upon 1 plus I the whole square. Express it in the form of a plus ib. Now I ask students to generally remember 1 minus I the whole square is going to be on minus 2i and 1 plus I the whole square will be plus 2i. Remember it. Going to be used a lot in a lot of questions. And when you divide them, simply you can see 2i getting cancelled, minus 1 is left. Well, how this comes, we can always solve. A minus b the whole square is a square minus 2ab plus b square upon a plus b the whole square, a square plus 2ab plus b square. You all can see 1 minus 2i, I square minus 1 and I square minus 1. 1, 1 cancel. Minus 2i upon plus 2i. 2i cancel. Answer is minus 1. Option B. And what I asked you to remember is on squaring 1 minus I the whole square, numerator is minus 2i. On squaring the denominator, it is plus 2i. That's it. 2-minute summary. I don't think 2-minute summary is needed. The chapter was very short and sweet for all of you. Complex number part 1. In the second part, there are questions on argand plane, representation, modulus, conjugate properties, argument. These things are there in second part. But do not worry. As you felt the first part, addition, subtraction, equality, all of this basics, very easy. The second part will also be easy. We'll do it later on. So the chapter is done from my side, part 1. Thank you so much, all of you, for watching this session. Keep watching, keep liking and keep smiling. Yeah. Thank you. Bye-bye.